Video number 108, solving nonlinear systems. Meaning you're going to have a system of equations, except the two equations are not lines. So in this case, these are circular equations. Well, the first equation is actually an ellipse. And the second equation, actually, we're going to come to find out in Chapter 6, this is actually a hyperbola. But nonetheless, they're nonlinear. And we are going to have various points of intersection, perhaps, that are going to be end up being the solutions to these these systems. All right. It says we need to add the two equations together to eliminate the y variables. All right. As you can see, that's probably the obvious choice. We do that. We get 5x squared equals 30. Divide by 5 square root. You get x equals plus or minus 6. These are the two x values of the intersections. So now we're going to find each of these two x values corresponding y value by going back and plugging it into either equation. And again, it doesn't matter which equation you plug it into because these are the x values that the intersection is occurring at. Well, if they're intersecting at this, obviously that means they're at the same height, which means the same y value will exist. So we plug in root 6 in for x. We get 18 because this just becomes 6 times 3, 18. Subtract, you get y is 0. So y is going to be 0 whenever x is root 6. Then we plug in negative root 6. Well, you're going to get the same exact thing because this is going to be just become a positive 18. That's going to be a positive 6 times 3, 0. So therefore, the 2 points of intersection, we're at root 6 comma 0 and negative root 6 comma 0. All right? So that's all we got for this first one. Now I got another example. All right. Now this is another hyperbolic shape. This is a hyperbola. This is probably some kind of hyperbolic shape. This particular equation is not necessarily studied in too much depth in your pre-calculus classes, but it is definitely a circular object of some kind because we do have the x and y that are squared. So anyway, let's go ahead, and what we're going to do is we're going to cancel both the x and y squareds out, okay? So if we multiply the second equation by 3, or perhaps by a negative 3, that's what we'll do. Yeah, negative 3. That's going to get the x's and y's to cancel. So now you'll have the first equation stays the same. Second one's going to be negative 3x squared plus 3y squared equals negative 15. When we add those equations together, we get xy equals negative 6. Now we're going to solve for y. Now it doesn't matter what variable you solve for, but if you solve for y, you'll get negative 6 over x. Now, you're going to use this negative 6 over x. We're going to go back to one of our original equations here and plug negative 6 over x in to y. Now, it's obviously the second equation's easier, so let's go ahead and proceed that way. So now we have x squared minus y squared equals 5. We plug in the negative 6 over x. We square first, then the minus sign comes down, so this is 36 over x squared. So now we have this equation, which is relatively easy for us to solve. Anytime we have an equation that's got fractions in it, we're going to multiply the equation all by that denominator. So we multiply everything by x squared. Well, that's going to make this a what? X to the 4th. Okay? So now we have x to the 4th minus 36 equals 5x squared. Are you okay with this cancelization here, right? See that? This x squared is going to cancel. This is going to go x to the 4th. That's going to go 5x squared. So here we are. Bam. All right? Now this is a factorable equation once we get it in standard form. And this is an equation that's in the quadratic form. And I have videos on that, equations that are in the quadratic form. So go back and check them out. You can factor x squared minus 9 times x squared plus 4. We get x squared equals 9. That gives us plus or minus 3 for x, or plus or minus 2i for the complex numbers. Okay? It says we now have 4 x values that solve the equation. I think you agree. We have 3, negative 3, 2i, and negative 2i. These 4 x values solve this equation. Now, remember, we need to find the points of intersection. So we're going to find their corresponding y values. All right. So now we're going to go back to one of the original equations, one of the first two. Again, obviously the second equation is easier, so we're going to use that. And we plug in 3, plus or minus 3. Now 3 squared is 9, but minus 3 squared is also 9. So plus or minus 3 is going to give you the same y value. So positive 3 gives us a 9. Subtract, you get negative 4. Divide by a negative, then square root, you get plus or minus 2. 3 comma 2, 3 comma negative 2. That's what this is saying when we did 3. But if you did negative 3, you would still get a 9. You'd still get a negative 4. You'd still get a plus or minus 2. So negative 3 gives you plus or minus 2. So you're getting 4 points of intersection from plugging in plus or minus 3. Then if we plug in 2i, okay, we go back to the easier equation. Plug in positive 2i. When you square 2i, you get negative 4. How do we do that? 2i squared is the same thing as 4i squared, right? 2i quantity squared is 2i times 2i. There's your 4i squared. There's your negative 4. Bam, right here. Now you're going to plus 4 to both sides. I kind of skipped a step here, but you're going to go plus 4 to both sides, and you're going to get what? Negative y squared equals 9, which gives you y squared equals negative 9. Now you're going to do the square root of both sides. You're going to get plus or minus 3i. Now how do we get plus or minus 3i? From plugging in 2i. So 2i comma positive 3i, and then this is 2i comma negative 3i. So there's the first two that we got. Then if you plug in negative 2i, that's the same thing as doing 2i. Because if you were to square this negative 2i, you would still get positive 4i squared, which is still negative 4. Okay? So therefore, you're still going to get the same y value. So then negative 2i gives you plus 3i or minus 3i. So then you end up with your 4 solutions. Alright? So if you have any questions, send me an email. Alright? Talk to you later.